Hey guys, so we are moving on to lesson 69, solving exponential applications using logs. So we have actually solved these word problems before. We solved them in the exponents unit, and we had to use some formulas that we had to memorize, and we could only solve them graphically at the time. So now we're going to be able to solve them algebraically using logs, just like we did in lesson 68. Okay, so remember that we have our general exponential formula, right? A times b to the x. So that b is going to vary depending on what kind of growth we're going to have. So we have the formula used for compounding interest n times a year. All right, so we said y equals a times 1 plus r divided by n to the nt. And a is the initial value. Sometimes it's p for principal when we're talking about money. R is our rate as a decimal. N is how many times it's compounded in the year. And then T is obviously the years. And then we have the compounding continuously formula. So y equals a times e to the kt. Again, it could be a, it could be p for principal. K is just like r. It's the rate as a decimal, but it can be negative if it's decaying continuously, whereas r is always going to be positive. And then t for time. All right, so those are the formulas that you already know that you still have to know. So really what we're focusing on here is the solving with the logs. The setup of it should be review. So it says Carla wants to start a college fund for her daughter Lila. She puts $63,000 into an account that grows at a rate of 2.55% per year, compounded monthly. So we need the words too. Write a function c of t that represents the amount of money in the account t years after the account is open, given that no more money is deposited into or withdrawn from the account. Calculate algebraically the number of years it will take for the account to reach $100,000 to the nearest hundredth of a year. All right, so there's actually two questions here. So make sure when it says to write a function that you write an equation that has c of t and t. Sometimes people skip that part and they just plug in the years in for t, or they plug in the c of t with the amount and don't actually give us a function. Okay, so we want to first start with c of t equals, we want our initial amount, $63,000, times 1 plus, we want the rate as a decimal. So we want that 2.55 divided by 100. So we want 0.0255 divided by n, which is monthly, which is 12, raised to the 12t. So that's the first question. Write a function. That's a function with t and with c of t. Now we can use that equation to answer whatever questions they ask us. So the question was calculate, and here's another keyword, algebraically the number of years it will take for the account to reach $100,000 to the nearest hundredth of a year. So the final amount, that's your c of t. So we're going to put that for c of t. So 100,000, make sure you have the right amount of zeros. And then you can put this part into the calculator. Just be careful that you're not rounding that number really at all. You can write, a bunch of decimals if it doesn't terminate. You can write a whole bunch of decimals after the fact, but I would keep that number in your calculator, even if you only write down a few of the decimals after, or the numbers after the decimal. That's fine. But if you round that number too soon, it's really going to affect your final amount. And I think I mentioned this in class a while ago. That happened on the last test. A couple people rounded that decimal and then were off by thousands of dollars. So it does make a difference. Okay, so that comes out. And again, you can leave it like that, or you can type that into the calculator if it's easier. I'm actually going to leave it. Okay. Now, if I was graphing this, I would just put this in y1, y2, second trace, intersect. That we've done before, find the answer. And you can still do that. And then just kind of know what the answer is supposed to be ahead of time, or check your answer graphically. But we still would have to show our work algebraically. And anytime I'm solving for the exponent, I'm always using logs. Okay, so the thing is, though, I can't put logs on both sides until the base that has the exponent is by itself. So this whole thing is the base. This is not being raised to the 12t. So let's get rid of that 63,000. Okay, so we can put that in our calculator. We can reduce it. You can write it really however you want, again, as long as you're not rounding. So I'm just going to write it as 100 over 63. And again, once again, you can rewrite this or you can round that. I'll just write 1.0258, put that in the calculator, and that's what you get. Okay, so now this looks more similar to some of the equations that we saw in the other lesson. And now we can put logs on both sides. So I'm just gonna... Okay guys, just to clarify where this number came from, it wasn't just here, which I circled before, it was this whole thing to the 12th power. So basically everything except for the t, right? Here's the a, everything here is the b, and then this is the t, okay? So this is 1.0258. And again, make sure you don't round too much. If you round to 1.03, that actually changes your final answer by about 3 years. So make sure you don't round too much, and even to be safe, keep the entire decimal in your calculator and copy and paste it. Of the left equals log of the right. And again, we can do this because we're doing it to both sides. Let's move this over a little bit. Okay, and the reason why we're putting logs on both sides is because of the log rules. So remember our third log rule? It's the same rule we used yesterday. It's the product rule. So when we... Hey, bud. You don't have to tiptoe, just don't scream, okay?
Okay, let me talk.
Well, I'm trying to record for my students.
So I just stay?
No, you can go or whisper, okay? Because I'm trying to teach my students.
Hey, help me.
Okay. See you in 5 minutes, okay? Okay, so t times log of 1.0258. And then you can just divide to get t by itself. Notice how I'm not putting any kind of other decimals. I'm waiting until the very end. And then I'm going to type everything in the calculator. This way my answer is as accurate as possible.
I'm sorry.
Okay, have fun. So then t equals, and I'm going to type this whole thing as is in the calculator. I'm not using log rules here. I'm not rewriting this. I'm not saying, oh, log with division, let me make a subtraction. Okay, it's not necessary. Just literally type this entire thing into the calculator and find your answer. And it said to round to the nearest hundredth, and therefore I get 18.14 years. And that's my answer. Okay, so if I were to have rounded this to, let's say, 1.03, right? This would have changed this definitely. By how much, I'm not quite sure, I can check, but it definitely would have changed at least the decimal part, if not, the 18 part. So that's really important to wait till the end to round. But really, the only new part is this log part. Yes, the numbers are bigger, the numbers are not nice, but the concept is the same. Okay, so you're always going to set up an equation using your exponential equation, whatever one is appropriate. Kieran. And then you're going to isolate the base.
I didn't watch it.
Oh, I messed something up.